So sweet. Hello, good morning, good afternoon, good whatever time zone you're in. My name is Igor Ljubuncic. I'm a developer advocate at Canonical, and I want to talk to you about Snaps today. I hope you will have a good virtual experience. Typically, it's not an easy thing to achieve interactiveness in a virtual session. So in advance, I'd like to say, if you guys want to ask questions throughout, type them down, and whoever is the moderator, if they can interrupt me and read the questions out loud, that's perfectly fine. I really don't mind. We don't have to wait 45 minutes or whatever time we take to ask questions at the end. So interactiveness, the more the merrier. Okay. So a little bit about myself. Like I said, I'm a developer advocate at Canonical. I've been working at Canonical 2 and a bit years. I have been a Linux guy all my life, apart from the secret fact that I'm a physicist by vocation. I write books, and I'm a big petrol head. As the image shows, that's me driving a Renault Megane at Spa-Francorchamps in Belgium, in the good old days when humans could roam the planet free. I have to say that I have to apologize in advance. There are going to be a lot of cliche jokes and 80s song references, but hopefully that will provide merriment for you to enter this session with joy. So what are we going to talk about today? I want to talk about snaps, basically why snaps and what kind of a technical problem they solve. I'm going to go into details around the architecture and the syntax. Basically, there's a language and an ecosystem behind this technology. I'm going to go briefly over how you publish to the Snap Store. And as you can see, the jokes are aplenty already on the third slide. And once again, I have to say, if you have any questions, just go for it. So what are snaps? So snaps are, on a philosophical level, an attempt to resolve a big outstanding issue in the Linux world, which is the fragmentation and non-portability of software code. On a technical level, snaps are self-contained software packages. Basically, you bundle all the bits and pieces that an application needs to run independently into an archive, and then you can port these freely around and use them on whichever Linux distribution you have. They're supposed to be simple and easy to publish. And of course, this is an ongoing process whereby we constantly engage the development community, try to learn as much as we can from developers and their experience, and then implement that into future versions of Snap technology so that it's even easier and faster to publish snaps. And one of the design feature is to have safe and automatic updates, something that is considered contentious on the desktop. However, something that has significant value and strategic impact in the IoT world and the cloud space. So just a quick question, how so far so good? The visuals, the audio, are you having fun? Are you having memories and flashbacks back to the 80s? I see lots of people are, okay, it's fine, cool. So let's talk about Linux, the classic Linux. You're all familiar with how Linux works, and to be able to package software and then distribute it on a classical Linux distribution, you need to have a good knowledge of Linux internals. And this also means understanding how different distributions are built, and they're not identical, how different packaging mechanisms and package managers work. This is also a non-trivial process, and when you do roll out code and there are updates, due to the nature of the application code, you could end up in situations where updates do not complete, or they complete partially, or you end up in a weird limbo state where an action wasn't fully committed, and it's kind of a transitional limbo state. This presents, okay, you know what, I'll ask you a question, guys. Have you had a Linux box go work on you when you run an update? Basically, you update your system and then something doesn't work. And I'm not talking about application logic, I'm talking about system breakages. So I see that the microphone is over amplified. I'll reduce the microphone volume. Is it any better now? Excellent. Thank you for that. So yes, as Jonathan says, dpackage for solves everything. Thank you, Jonathan. I think we can end the discussion early. So I told you about a problem, but then again, why snaps? I mean, is this the solution to this problem? I'd say that it is a solution. And of course, everyone would love to believe that what they do is the best and the most elegant thing around. But we generally believe that this approach can transform and advance Linux from its current state of fragmentation and non-portability into something that is more transparent to the end user. I'll do a little bit of promotional verbiage, so feel free to just ignore this part if you're not keen on promotional propaganda. But basically, snaps are available to millions of users, and it's not just Ubuntu, although you have snap support from version 14.04. Snaps are available on 40 plus different Linux distributions, just to name a few: Arch Linux, Manjaro, Fedora, Debian, CentOS, and so forth. And in the Snap Store, you are welcome to host your code regardless of your licensing mechanism. It can be closed source, proprietary, open source, whatever you fancy. You can host it and distribute to your end users. The idea is simplicity above all. Basically, there's one snap per hardware architecture. So let's say AMD64 or ARM-HF, and you distribute that one snap to all the supported systems that have snap support. So you don't have to think about, do I have to make custom changes for CentOS? Do I need to make custom changes for a specific version of Manjaro? Or will this work on an old version of Ubuntu? The idea is, if it's supported, it should run well and it should run consistently. Sometimes there can be problems, and we always strive to address them as well as we can. But we aim to achieve as much consistency and as few moving parts and thus unknowns through snaps. Another benefit that developers can have is analytics. When you create a developer account in the Snap Store and you go through different menus and options that you have there as a developer, you will also find that for each individual snap that you publish, you will also have an analytics page. And on this page, you will be able to see how your Snap active usage is trending, including breakdowns in terms of time, version, operating system, and a few other qualifiers. And then you can also correlate to perhaps social media engagement, campaigns, release of new versions, or just anything happening out there. And it can also help you make more numbers-driven decisions around your development. You also have a full control of your update cycle. Basically, as soon as you feel confident enough to publish an update, you can. The updates are cryptographically signed, which means that if you work with a Snap Store or a Snap proxy, you have a guarantee that what you're getting is non-tempered code. You also have a high level of granularity, whereby you can differentiate how you distribute your code. So you could also have, for instance, an edge version of your application. Then you can also have a candidate version or a stable version. You can also have different tracks so that you support multiple versions in parallel. And this gives you granularity and your users flexibility. Even if a system is potentially out of date, you can still have snaps updating and providing users with functionality and security that they need. And lastly, as I mentioned previously, you have automatic updates, and by default, the Snap system service will check for updates 4 times a day, as you can see by my lovely joke at the bottom of the slide. However, you do have control over the update mechanism, and you can manually set and defer updates up to 60 days. So the 4 times a day can be as little as once every 2 months. Any questions so far? Any comments on the jokes again? I see someone is typing. Hopefully for me. Okay, while the typing is being done, let's talk about how snaps work. So snaps basically come in, there are 3 plus 1 major components. There's the snapd service, which runs in the background, and it is the management engine for all snap-related things. Then there's the user space component, the snap commands. So you use the snap command like snap install or snap remove, or snap search, and so forth. So these commands help you discover what you need and interface with the snap ecosystem. There's the snap store as well, which is the front end. You have the web-based front end, but you can also use any application package manager, the graphical package manager that supports snaps in the backend. For instance, GNOME software, KD Discover, and so forth. And finally, for developers, there's the Snapcraft command line tool, which you can use to build and publish snaps. Now, don't get too excited. This is probably not the most exciting diagram you've ever seen, but basically this is just a diagram that shows how the snap components work. You have the snap store, which is the one store, authoritative place where the code is hosted and from which you query information from. There is the snapd service and the user space component, and finally the Snapcraft tool to develop snaps. So what can Snapcraft do for you? So it builds snaps, pure and simple. And upon a successful completion of a build process, you will have 1 or more snaps. And when I say 1 or more, you build a project, but you can build it for multiple architectures. A snap is a squashfs file system. It's compressed. If you follow the news lately, you will have also heard that we recently did a change in the compression we do to improve performance and startup times of different snaps. So that's something that could be potentially interesting for you to have a read after this session. And inside that single file system, you will find all of the application code and declarative metadata that the application requires to run. And just finally, the snaps have a .snap extension. So now we know more or less what the architecture looks like, and it's time to develop a snap, just to actually write your first snap. And so how you do that is you need to create a file called Snapcraft.yaml. It's in YAML syntax, so you need some familiarity with the YAML language to understand declarative clauses in the code. And in a way, if you come from the traditional Linux world and you have built applications, let's say RPMs, then if you're familiar with the RPM spec files, there is some commonality in logic in how that is done to how you build snaps with Snapcraft.yaml. Here's an example. So the actual code that I'm going to show you now is just representative, and it's also a fairly trivial example. I will not go into far more detailed example right now, so please excuse me if things feel oversimplified. But for the sake of time and simplicity in this session, I'm just going to show you a very simple command line weather utility that all it does is gives you your forecast in your location when you run it from the command line. As it happens, it's a Node application, and it's one of the many different languages and frameworks that we support in Snapcraft, which I'll touch upon briefly a bit later. So a couple more seconds for you to have a look at what this YAML looks like, and then we'll go into each section and explain the syntax and the meaning of different entries that you see here. So the first part of the code is metadata, basically identifiers through which your application gains uniqueness and discoverability. So you give your application a name, you give it a version. The version can also be a branch of your GitHub project, for instance, or tied to any versioning control mechanisms you have to determine what the application is, what the application version is. Then there's the summary, basically a one-liner to help identify what your application does when someone does a search, and a description which also supports Markdown. So you can have a rich description with bullets and italic and bolded text and so forth. This is a table that shows you the rules for what you can or cannot do when you write your metadata. Basically, it's all strings. The version number is not a numerical qualifier that you have to abide by with, so you can have anything for your version as long as it makes sense to you and your users. And there are also some limitations on the length and size of the fields. So yeah, we're just warming up. So let's look at the more interesting things. The second part, which we'll touch upon briefly very soon again, is the confined. And this is a novel concept for people coming from traditional Linux, because if you have a regular Linux application installed in your system, technically it's unbounded. Basically, it can touch pretty much any part of the operating system within the privileges that that user has. And with snaps, things are different. Snaps were originally are a continuation of the clicks format that was used for Ubuntu Phone. And with the phone, there was a strong emphasis on isolation and compartmentalization of applications for security reasons. And this was transitioned also into snaps. And the idea is that each snap lives in its own individual world and cannot easily interact with other applications. Of course, that would make applications useless if they couldn't do anything outside the boundary inside which they exist. So there's a granular mechanism, which we call interfaces, which allows you to punch very controlled holes in the snap confinement and then interface with different system resources. For instance, an application may need to be able to access files in the home directory, or an application may need network access, or may need access to USB devices, OpenGL, and so audio, and so forth. I see that there is a question about the centralized distribution of snaps. This is a question that I will not address right now. Apologies for that. I'm not deflecting. It's a more complicated topic that I will refer you to. We have an extensive series of Q&As and topics that we're addressing and discussing with our community on our website. And one of the questions is around this. So I'll refer you to a more authoritative reply with far more details than I can give in this session. So confinement level. There are basically three levels. There is strict, dev mode, and classic. Strict is the strictest level that a snap can have. And by default, snaps that are strictly confined with no interfaces defined can't really do much. They can just basically exist as code in memory, and that's it. Very useless. So you do need to provide overrides with interfaces. Dev mode is basically strict with soft errors and warnings rather than hard errors and warnings. So if you're developing an application and you would like to figure out which parts of the system it wants to touch, then you use dev mode, you get all the errors, but without hard failures, and then you can provide the granular interface overrides as you need. Finally, for applications that cannot immediately be confined as strict, there's a classic confinement method, which we discourage because it basically gives you system level access like any traditional application. That means that you can break your system, you can break your snap by running updates on the system and so forth. And it's really a stopgap measure, and you can't just publish a snap manually, automatically. It has to go through a security review and so forth. So the main idea is for you to think about dev mode and strict, and use an extensive range of interfaces to get the functionality you need. So our weather application, yes.
You got another question.
Yes, please.
Any plans to add runtime permissions to snaps, something like Android's runtime permission for camera access, microphone access, file system access, etc.?
If I understand the question correctly, the idea is then, for instance, you need webcam, but then only at runtime you allow yes, no, rather than to have it predefined before. Is that the meaning of the question? Basically that you have some kind of a visual prompt by which you allow deny in a UI.
see, the Oscar writes more. Yes, something like a visual.
Okay, so it is doable today. However, it's not doable visually in terms of UI. It's doable on the command line. So you can install a snap. You can, before you run it, check what interfaces it has defined and which ones are connected, so to speak. And then you can manually use snap connect or disconnect to connect or disconnect its specific interfaces. So for instance, you install a snap which you don't fully trust. And you say, okay, I'll snap disconnect its network, see what it does, kind of figure out if it's an application you like. And then if you like, you allow the network. Or you can say snap disconnect camera and continue using that application without it being able to access the camera. Now, the thing is, if the application logic is hard-coded to expect certain privileges and they're denied, you may get unexpected errors. So you can, at runtime, deny snap access to specific resources that the snap needs, but be aware that the application may not handle it gracefully. It really depends on how the application is coded.
And there was some more added, another comment. Isn't this SKD desktop portals which Snap support as well? I think they wonder if they can do it with XDG desktop portals.
Say again, please. I didn't hear well the question.
Oh, sorry. There was another comment. Isn't this SDG desktop portals which Snap supports as well?
That is one of the things, but it's not everything, because you need to really look at how long the list of interfaces is, and they really cover everything. They also include things like process monitoring, mount observe, so you can see whether, so you can cross file system mount points and see file sizes or mount file systems. There are things like personal files, being able to access hidden files in your home directory. There's dbus and so forth. So it goes much more than just accessing very specific things in the user session. And the idea is basically that we provide this so that people can have strict confinement and very granular control rather than defaulting to, let's say, classic, because doesn't give them everything they need. I'll continue. If there are any other questions, absolutely feel free to ask. So how the application isolation works, astounding graphics again. Basically, you have the read-only code, which is the snap code, and it cannot be changed. But then to make the application useful over multiple sessions, there's also an app-specific writable area. And there are multiple writable areas, including areas that can be ported and used across multiple snap updates or snap versions, if you will. There's confinement. Confinement is done through multiple mechanisms. There's AppArmor, there's cgroups, seccomp, so forth. Of course, on other distributions, in some cases, some of the confinement mechanisms may not necessarily work because they don't exist or are not supported in those distributions. So you will have partial confinement. So you will have only some levels of security rather than the whole gamut that is designed in the Snap ecosystem. And then you have the core snap, basically the heart of the snap functionality behind the scenes, upon which the snaps rely and use, and we'll touch that in a second. And so you have the application code running, you have the confinement, and then you have the core snap to provide basically a file system for snaps to run and exist on a host. So a bit more about the base. Like I said, snaps are confined, so they don't really see the real file system, but they still rely on certain elements, certain directories and libraries to exist to be able to run. So what we have in the Snap ecosystem is a base, basically a special kind of snap with a minimal set of libraries, sometimes a little bit more than a minimal set of libraries, and additional assets which are required to provide consistent runtime experience for snaps. And they are usually aligned to different versions of Ubuntu. And now this can sound a little bit confusing, but if you build your snap, say, against Core 18, which would be 1804, that doesn't mean that if you run on Fedora, that you're running on. That doesn't mean you need a Fedora base. Inside the Snap, you'll still get all the libraries from the Ubuntu core 18, and the Snapd service on Fedora will do the necessary translations and the necessary abstractions to make sure that the Snap runs consistently. So when you build your Snap, you can decide on a base that basically defines what libraries and packages you have and what you can use at your during development time. And of course, if this is not sufficient for you and you have different requirements, you can actually, well, write your own base. Now, the build definition. There are two parts. Yes, please. I hear a question.
You got a question/comment. There's an issue with slow Snap run times due to compression. Is it possible to disable compression completely?
Okay, so two answers to that. One, we would like to believe that there are no more problems with it, and if there are, please let us know. Go to the forum or file a bug. We take these things seriously. We have a whole series of articles written recently around compression, improvements, troubleshooting, performance optimizations with hot startups, cold startups, first-run startups, everything. So we would like to believe that we have improved things considerably. That said, it is possible that there are issues, and it is possible that you may want to use no compression whatsoever. I don't have an immediate answer whether the store team or the security team will accept that as a valid option, but please do start a thread on our forum perhaps, and we'll see where we go with that.
Then you have a tricky question.
Wait, one second. Before a tricky question, we also have Ken from the desktop team here, a fellow canonicler, and he has just written that LZO is practically no compression. Ken is the man, basically. He knows everything Snap and desktop related as well. So if you have any questions that you feel I'm not giving you a sufficiently good answer, you can also ask Ken.
I was mostly joking, by the way. The question is, can Flatpak and Snap merge efforts and become one thing?
From a physical perspective, if we look at the second law of thermodynamics, there's nothing that prevents any two open source Linux projects from working on cooperating. What is that that's doable on a practical level right now, I can't say. I mean, it would be maybe even arrogant of me to go gushy and say, yeah, we can all work together and put aside every single difference that exists. I would like to believe that this is doable, but there are also practical technical differences that need to be addressed. However, we welcome cooperation, we welcome sharing, and if we can do better for the Linux community, any which way is welcome and possible. And as Ken says, we do cooperate, but the more the merrier. And if you have suggestions and ideas and concrete proposals on to how to do that, again, please join our forum, start a thread, anything you fancy, and we'll take it seriously. We're not going to ignore things. So, build definition. Two parts, and please don't get confused because I use the word parts as one of the parts is written on the screen. There is the application declaration, and there is the build declaration. The parts part is where you define how your application is going to be built. And by build, we're talking about a whole range of possibilities. You could reuse an existing binary. You could extract an existing Debian package, or you could compile from source, and you can compile a whole range of languages. You can use Python, you can use Java, you can use C++, you can use Node, Ruby. We also support robotic space languages like ROS and Moose, and a whole range of others. Recently, we also have support for Flutter. So we are branching out as much as we can to provide as much support for development languages and frameworks. And then the application declaration is basically you define how your application is going to run and what kind of permissions or system resource access it will require. And that is done through a keyword called plugs. Basically, it defines into which interface you plug your application. So for instance, weather being a command line utility that needs to query meteorological services out there, it needs network access. So we define network access. And if you deny this application network access, it can't really provide you up-to-date forecast. So what I said now, also written with bullets on the screen. We have the application declaration as a block. We have a command path to an executable. And again, executable can be a script, or can be a binary, or any which way by which you would start your application. And then the resources you need for strict confinement. Parts, similarly, we define the bits and pieces we need to assemble our application. There could be one or more parts. We have a plugin, and in this case, we use a Node.js plugin. And here I'd like to emphasize a bit more. Plugins is another mechanism we have implemented in Snapcraft to try to simplify development. Basically, rather than you having to know every little bit about Node and how to use it, we provide a baseline template, if you will, for users, and in this case, developers, to be able to more quickly iterate on their code. This does not mean that you should be clueless or not understand at all how your application or application language works, but using plugins, you can simplify your development, perhaps achieve a higher level of commonality, and gain some speed because you already have reusable components. For Node.js, you will have specific keywords. For other plugins, for let's say Python or Ruby, you will have different keywords because the languages are different. Before I touch on Snapcraft commands, I'd just like to emphasize something, and I would actually even like input from Jonathan Riddle, if he is available and can turn his microphone on. There's something called extensions. So we have also developed an even more abstract mechanism for for Snap development called extensions. An extension basically hides away lots of common pieces that you need to build an application against a framework. We have GNOME Desktop extension, we have KDE Neon extension. And Jonathan could potentially here maybe mention a word or two, if he wants, about his experience with the extension. The idea is basically you reuse parts, your Snap becomes much smaller in size, and you have a much better consistency because you don't manually play around and with specific components, and you maybe miss a theme or you maybe miss a library. It's all bundled in a common framework and all behind the scenes. So Jonathan, if you can turn your mic on, if it's possible. If not, yeah, there you go. Hello.
What's the question? Am I famous?
Yes, you are famous, and if you could say a couple of words about the KDE Neon extension, if you like.
I haven't used it very much. We've got the content snap, and that is built using all the KDE frameworks, all the libraries that KDE applications use. We build those as part of KDE Neon for our normal debian.deb apps package archive, but we also have a job that grabs those, turns them into a snap, so that if you are making any KDE application, then it can be based on this content snap, and that will have all the KDE libraries available by default. Was that your question, or you were asking about the extension?
You're golden. I'll continue. Thank you. Mm-hmm. So what Jonathan said, and we take it one step further. So you have the content snap, you have the commonly reusable KDE Neon components, and on top of that, you can also add common themes, you can add desktop integration, and you can add a few other bits and pieces. And you all declare all that just by using a one-liner. So you basically say extension, KDE Neon, and Bob's your uncle. Or if Bob's not your uncle, then someone else. But you get the idea. I hope the jokes are appropriate. So Snapcraft commands. Now you have your YAML, it's time to build. And there's a whole bunch of commands you can run with Snapcraft. Basically, you can just do Snapcraft and your Snapcraft builds. You can use multipass in the backend, which will spawn virtual machines and build in an isolated environment so it doesn't touch your file system. Or you can use containers, LXD, if multipass is not an option. You can iterate and clean specific parts of your Snap project if you encounter any errors or problems. You can also step into the built environment if there are issues, so you can troubleshoot live and understand if something's wrong, and so forth. Basically, like I said, all you need to do is just do a one-liner. I got an error that says connection failed when sharing screen. Did anyone else see that? And did you lose me?
We have you, but your slides seem to have disappeared.
Yes.
Your slides.
Okay, I'll try to share again. Do you see the slides? Okay. All right. So we're back in the game. Okay, cool. So all you need to do is just run Snapcraft. And if you've written your code well and there are no errors, it should complete just fine and you will have your Snapcraft artifact. So just as a crude example, I compiled something called tkdm and ran Snapcraft, and you have the green lines. Green is good, means no errors. And in the end, it says snap, name of the snap.snap, and that's it. Now that this step is done, it's time to actually see what the snap contains. So you can take your snap, the squashfs file system, and you can unsquash it, or you can mount it as a loopback device. And then you will see that inside it looks like a typical Linux file system, except it all lives inside this archive. You have bin, etc, lib, user, and so forth. And in these directories, there will be libraries, there will be binaries, any which asset that your application needs and requires. So in practical terms, let's say that you require libigor.so, a shared library. So you actually use the library from within the snap. You don't use the one that's available on your file system. And let's say that you delete that shared library on your file, or there's a system update that changes the version, your snap is unaffected. Your snap will continue running with the application code it expects to have and will not be impacted by any other application or any update on your system. A few other bits and pieces for you to take into account. There are a range of snap variables, some of which you can declare in your YAML, and others which you can refer to when you're troubleshooting or debugging your snaps. So, for instance, the read-only path, or the writable data, or the user data, and others. At this point, I would like to refer you to the documentation online and have a look for yourselves. And this will give you an additional understanding of how snaps work and how you interact with snaps and Snapcraft during development. Now the fun part, which is publishing your snap. So once you have the snap ready, you need to do three simple things. One is create the development account on the Snap Store. You click the button, you go through the process, and then you're a developer and you can upload one or more snaps, plus quite a few other things like add collaborators and so forth. Then you need to register your application name. Ideally, it will be a name that's not taken by someone else, and it will be unique to your project. So you don't go and say register KDE for something that has nothing to do with KDE, for instance. And finally, then you upload your snap and polish up your page so that the application looks presentable, it's beautiful and elegant and appealing to your end users, and the snap begins its life as a product for consumers. How you do this? You do it on a command line, and you have the option to push your snap to a different channel. Not just by default, you have lots of variations here. And here I need to go into a concept that's quite interesting, and it's store channels. In the Snap Store, you have a three-dimensional matrix of possibilities on how you promote your code and how you provide it to your users. You can use tracks, which allow you to have multiple versions of your application available, if you like. You can use a risk level, basically supported releases, multiple supported releases of the same application. And then you can also have branches for optional testing and debugging. Basically, you make a tiny change. It could be Igor with LZO compression, and your colleagues or people who you work with or your beta testers can then download and test this specific release of your snap before you promote it to the stable channel to the wide audience. So some examples of what kind of tracks you could use. There's always the default track, which is latest, but you can use anything you like. Risks, there's stable, candidate, beta, edge, and a question. Yes, please.
Last question before your time is up. In future, we will see Ubuntu Core as the main Ubuntu with all applications as Snap, something like immutable base with sandboxed applications.
The simplest answer I have is perhaps. I don't have a definitive answer for that. Sorry if I'm being vague, but I don't have more to say. And again, not because I'm trying to do plausible deniability or drama effect, I just don't have an answer for that. You said lots of questions. What's next?
Now the time is up.
Is it? I thought I had a full hour based on what I've seen.
All right, the schedule says that the next talk starts in 3-4 minutes.
Okay, then I'll breeze through quickly. So you upload to the store. Don't use stable right away. There could be automatic checks and manual checks if your Snap doesn't pass the security requirements right away. Make sure you have a compelling page so that beautiful screenshots, potentially videos, rich description, so people see your Snap, they will want to interact, download, and use it. So I guess I'm on time, or not, but yeah. Anything else before we part in tears? Thank you all. I hope you enjoyed it. Have fun. Reach out if you have any questions. We're really here to help and work with you guys.